Have you ever wondered why some students effortlessly ace their exams while others struggle, despite spending just as many hours studying? Why do some people retain information for years while others forget everything the moment the test is over? If you believe the difference lies in natural intelligence or IQ, you are operating under a costly misunderstanding. The true separator between top students and average ones is not how much they study, but how they study. Most learners fall back on traditional passive methods, rereading notes, highlighting entire paragraphs, and cramming information the night before an assessment. These techniques feel productive, but cognitive science confirms they are scientifically inefficient. They create what is known as the illusion of fluency. The material looks familiar, so your brain tricks you into thinking you know it, even though you lack the ability to retrieve it under pressure. This process is a massive waste of time, energy, and potential. The world's highest achievers, from elite university students to Nobel laureates, operate with a different playbook. They utilize learning strategies that are engineered to work with the brain's natural mechanisms for memory encoding and retrieval. These are not insider secrets reserved for the gifted. They are systematic, replicable techniques accessible to anyone willing to abandon outdated habits. Today, we are going to break down 4 powerful evidence-based study techniques that will fundamentally transform your learning process, allowing you to absorb information faster, understand concepts deeper, and retain knowledge permanently. And pay close attention to the final technique, as it is the foundation upon which all long-term memory is built. Let's begin with technique number 1, active recall. Active recall is the process of deliberately forcing your brain to retrieve information from memory rather than passively reviewing it. If passive reading is like looking at the map, active recall is navigating the terrain without it. The struggle involved in retrieval is the key ingredient for deep learning. When you struggle to remember, you strengthen the neural pathways associated with that information. To implement active recall, you must move beyond simply recognizing material. The process can be broken down into 5 steps. First, study a small section of material focusing on understanding the core concepts. Second, immediately close the book or lecture slides. Third, actively test yourself. This can involve writing down every key point you remember on a blank sheet of paper, using flashcards, or generating questions about the content and answering them aloud. Fourth, compare your retrieved information with the source material to identify precisely where your knowledge gaps exist. Fifth, focus your next study period exclusively on those identified weak points and then repeat the retrieval process. The power of this technique lies in the testing effect. Numerous studies, including landmark research by cognitive scientists like Jeffrey Karpik, demonstrate that testing yourself is vastly superior for long-term retention compared to mere rereading. Every time you successfully recall an answer, you are cementing that memory. If you find the process difficult, that is a positive sign. It means your brain is actively working to build stronger connections. Stop reading to understand and start testing to remember. Technique number 2, the Feynman technique. The Feynman technique, named after the brilliant physicist Richard Feynman, is the ultimate method for achieving deep conceptual understanding. It is founded on the simple premise: if you cannot explain a concept simply, you do not understand it well enough. This technique is designed to expose the difference between memorizing terminology and truly grasping the underlying mechanics of an idea. To master any complex subject, follow these 4 steps. First, select the concept you want to learn and write its title at the top of a blank page. Second, explain the concept in your own words, as if you were teaching it to a 5-year-old or a complete beginner with no prior knowledge. Use simple, non-technical language and avoid jargon. Third, identify your knowledge gaps. Inevitably, you will get stuck or realize your explanation is vague or reliant on complex terms. These are your blind spots. Go back to your source material and study those specific areas until you can explain them clearly. Fourth, simplify and refine. Once you have filled the gaps, review your explanation. If it still sounds complicated, use analogies and visual metaphors to simplify the language until the explanation is crystal clear and uses only basic vocabulary. The true genius of the Feynman technique is that the act of simplifying forces synthesis. It compels you to organize your thoughts logically and create connections between ideas, transforming fragmented facts into a cohesive mental model. This is why top students do not just memorize formulas, they understand the foundational principles that govern them. This technique turns passive learning into active creation, ensuring mastery rather than rote memorization. Technique number 3, the Pomodoro Technique. The greatest enemy of effective study is not lack of ability, but lack of sustained focus and the debilitating effect of burnout. The Pomodoro Technique, developed by Francesco Cirillo, is a time management system that structures work into short, intense sprints, maximizing concentration and minimizing mental fatigue. It recognizes that the human brain performs optimally in focused bursts, not extended, unstructured marathons. The standard Pomodoro cycle is simple yet powerful. First, select a task and set a timer for 25 minutes. This 25-minute period is your Pomodoro, a time dedicated to total, uninterrupted focus. Eliminate all distractions, silence your phone, close irrelevant tabs, and commit fully to the task at hand. Second, when the timer rings, stop working immediately. This is crucial for training your brain to work effectively within time constraints. Third, take a short 5-minute break. Use this time to step away from your workspace, stretch, hydrate, or simply rest your eyes. Do not engage in mentally taxing activities like checking social media. Fourth, after completing 4 consecutive Pomodoros, take a longer restorative break of 20 to 30 minutes. This structured approach prevents the common pitfall of decision fatigue and procrastination, as the task becomes less daunting when broken into manageable 25-minute chunks. By enforcing regular breaks, you allow your cognitive resources to replenish and enable the consolidation of newly learned information. Studies show that this method significantly improves perceived productivity and reduces the feeling of being overwhelmed, turning long study sessions into a series of highly efficient sprints. Technique number 4, spaced repetition. If active recall helps you encode information deeply and the Feynman technique helps you understand it, spaced repetition is the secret weapon for ensuring you never forget it. This technique is the scientific antidote to cramming. Cramming relies on mass practice, which creates temporary familiarity that rapidly decays, a phenomenon known as the forgetting curve. Spaced repetition, conversely, leverages the spacing effect, a robust psychological principle stating that memory is optimized when learning attempts are distributed over increasing intervals of time. The system is based on strategically reviewing material just as you are about to forget it. Imagine your memory strength for a topic. After initial learning, the strength drops quickly. A review session resets that curve, and the next time the drop is slower. By extending the time between subsequent reviews, you force your brain to work harder, which strengthens the memory trace each time. A typical spaced repetition schedule looks like this: initial study, review after 1 day, review again after 3 days, then a week, then 2 weeks, then a month. Because manually tracking these intervals is complex, highly effective digital tools like Anki or Quizlet utilize sophisticated algorithms to automate this process, presenting specific pieces of information, often in flashcard format, precisely when your brain needs to see them next. The long-term evidence for spaced repetition is overwhelming. It transforms studying from a reactive, stressful scramble before an exam into a proactive, low-effort maintenance system. By replacing large, stressful review sessions with small, frequent, and increasingly spaced reviews, you effectively slow the forgetting curve to a near halt, making vast quantities of knowledge available for years, not just days. To truly unlock your learning potential, the most powerful strategy is to integrate these 4 techniques into a unified system. Do not view them as standalone methods, but as complementary tools in your academic toolkit. Start by using the Pomodoro technique to define your study structure. Commit to intense, focused 25-minute sprints. Within those sprints, employ active recall and the Feynman technique. When learning new concepts, use the Feynman method to ensure deep understanding by explaining the idea simply. Once you have grasped the concept, immediately switch to active recall by closing your notes and testing yourself on the key points. Finally, use spaced repetition software to schedule your future reviews of the key facts, definitions, and concepts you successfully recalled during your active recall session. This integrated approach means you are structuring your time effectively, understanding the material deeply, encoding the information strongly, and ensuring permanent retention. It is a system designed for maximum efficiency and minimum waste. The transition from struggling to effortless recall is not a matter of luck or innate talent. It is a matter of adopting proven, evidence-based methods. Your action plan is straightforward. Choose one subject you are currently studying and apply just one of these techniques: active recall, Feynman, Pomodoro, or spaced repetition in your next session. Observe the immediate difference in your focus and your ability to retrieve information later. The results will provide the evidence you need to transform your entire approach to learning. Stop working harder and start working smarter.